Hello, and welcome once again to the Scientific Adventures of Beardman. Well, today we're going to look at the situation where we're solving a physics problem and the equation we're using is not already arranged to solve for the thing that's our unknown. Okay, so our unknown might be on the same side with another variable, it might be in the denominator, it might be a different place. So there are a few basic strategies to get it by itself in the numerator, which is our goal. Our goal is to get the unknown in the numerator and by itself. Most of what we're going to be talking about on this video is dealing with situations where all the functions that we're dealing with are multiplication and division. You'll have to use other algebraic tricks to be able to deal with situations where there's addition and subtraction. But hopefully you learned most of those anyways. But this is a review of the multiplication division situation. So the first thing in order to get it in the numerator by itself is to get it into the numerator. First of all, that's easy if it's already in the numerator. If your unknown is in the denominator, then just multiply both sides by your unknown. Then that will cancel it out of the one side and leave it in the numerator on the other side of the equation. Once you're done with that, then you have to get rid of the other things that it's attached to. So the first question you ask yourself is, what is it attached to and how is it attached? For example, an M might be attached to an A and it might be attached by multiplication. Well, if it's attached by multiplication, then you do the opposite. You have to divide by A, and whenever you do something to one side, you have to do it to the other. So you divide by A, which cancels it out on the side with the M, and leaves you with a M in the denominator on the other side of the equation. Just don't forget, you can do anything to the equation you want as long as you do the same thing to both sides of the equation. You might have learned this as the golden rule of algebra. Do unto one side as you do unto the other. And once you do this, you got the equation, the unknown by itself, and you can continue with the 5 steps and begin plugging in and solving your equation. We'll be looking at 3 sample equations here. As we go through this, we'll look at steps 1 through 5. Of course, right now our focus is on number 3. And so we'll look at 2 where you start with the unknown in the numerator. And then we'll look at a third one where your unknown begins in the denominator and you have to put it into the numerator. So watch these 3 examples and hopefully by the time you're done you'll feel comfortable solving any equation you get in physics, at least that involves multiplication and division.
A handheld fan with a resistance of 3 horseshoes, or ohms we'll learn later, but we'll just call it horseshoes for now, is run using a battery with a voltage of 9V. What is the current through the fan? So the first thing we have to do is figure out what we've been given, okay? And we can see that we are given 3 horseshoes, and what is that? Well, it's a resistance. We look up on our sheet that I gave you, and you will see that resistance is capital R. So capital R is 3 horseshoes. Next we see 9V, and it says it's a voltage of 9V, so we look up voltage, that's capital V, so we get capital V equals 9V. Then finally we see what is the current through the fan, and so we look up current, and we find current is capital I. Since that's the thing we're looking for, then we will just put I equals question mark. So now we go to our California reference sheet, and we look up for an equation that has R, capital V, and capital I. And we see V equals IR, which is labeled as Ohm's law. And we can't just plug in right away. We have to do some rearranging because we're solving for I. And if that's our unknown, that means we have to get I by itself in the numerator. Other way around, in the numerator by itself. Okay, so it's already in the numerator. So we just have to get it by itself, which means getting rid of this R. Well, how do we get rid of it? Well, if we divide both sides of the equation by R, then on this side we have R divided by R, which gives us 1. And of course, I times 1 is I. So that essentially cancels out the R's. And we're left with the following equation. I equals V over R. or written here, I equals V over R. Then we plug in, V is 9 volts, that goes in the numerator. R is in the denominator, so 3 ohms goes in the denominator, and that's step 4, plugging it in. 9 volts over, or 9V over 3 horseshoes. Then we divide, 9 divided by 3 is 3, and we'll just leave it at V over horseshoes. Later we'll learn that's the same thing as an amp.
And now here is the second example that we have.
A garbage truck operator uses her truck to push a car with a force of 20,000 N and does 60,000 J of work. What distance does she push the car? Okay, so remember, once again, we're looking for our numbers and figuring out what variables they belong to. So here we see 20,000 N. What is that? Well, it's a force of 20,000 N. So force is our variable. We look that up on the sheet I gave you. You see force is a capital F. So capital F is 20,000 newtons. Our next number is 60,000 J, and it says 60,000 J of work. So work is what it is. That's a capital W if you look on the sheet. 60,000 J is equal to capital W. What distance does she push the car? Now, distance has several different variables in the sheet I gave you. It could be delta X or R or D. So you probably at this point could write any one of those and then narrow it down later. I happen to know it's going to be D, so I'll put that straight off. So now we look for an equation that has capital F, W, and then one of those variables we talked about. In this case, it would be the work equation, W equals FD. Okay, so now everyone would know that it would be D that would be the variable in there, because it's the only one with an equation that also has capital W and capital F that has some sort of distance variable. So at this point now, because we're solving for D, we're going to need to rearrange this equation. We need to get D in the numerator. Well, it's already there. And then we need to get it by itself, which means we have to get rid of this F. So we can get rid of the F by dividing both sides by F. That makes F divided by F, which gives us 1. And of course, D times 1 is just D. So we can just cross these out. Okay, so we get D equals W over F. D equals W over F. Now we plug in. W is 60,000 J. F is 20,000 N. So we put 60,000 J in the numerator, 20,000 N in the denominator. 60,000 divided by 20,000 gives us 3. And J over N would be our units. Later, I'll show you how that cancels down to meters.
And now here we can see the third example. In this third example, now remember, we're going to be dealing with a situation where the unknown begins in the denominator. So you'll see that extra step here.
So here's our first sample problem. A current of 5A travels through a wire. How much time does it take 15C of charge to flow through the wire? So we take a look. The first thing we notice here is we see a number 5A. What is that? Well, it's a current. And if you look on the sheet of paper that I gave you, we can see that current is symbolized by a capital I. So we write I equals 5A. Then we see, the next thing we see is time. It says how much time does it take? So time is the thing we're looking for. We look up time, we see lowercase t is time, so we write t equals question mark, showing that it's our unknown that we're going to try and find. And then it says, does it take 15C? Here's another number. What's that? Well, 15C of charge. If you look up charge, you'll see a lowercase q. So lowercase q equals 15C. At this point, now we'll take a look at our equation sheet, our blue equation sheet, California Physics Reference Sheet, and look for an equation that has capital I, lowercase t, and lowercase q. And the equation you'll find is labeled is labeled current, and it's I equals lowercase q over lowercase t. So now we have to solve for t, because t is the unknown. So let's rearrange this equation for t. So the first thing we have to be sure we do is get the t into the numerator. Well, how do we get the t in the numerator? We multiply both sides by t. like this. That will allow us to cross off the t in the numerator on the right and the t in the denominator on the right, because t divided by t is 1. So we can just cross those out because q times 1 is just q. So now we have t in the numerator. Now we got to get it by itself. And so we're going to have to get rid of this I, so that the t is left by itself. So how do we get rid of the I? Well, let's divide by it. If we divide by it, we have I divided by I. Don't forget, whatever you do to one side of the equation, you have to do to the other side of the equation. That'll cancel out these two i's. I divided by I is 1. And we're left with t equals q over I. And that will be our final rearranged equation. At this point, we go back to our original steps 4 and 5, which are to plug into the equation. We can see that q is 15, so in the numerator we'll put 15. In the denominator we have I, which is 5a, so we have 15c over 5a. 15 divided by 5 gives us 3, and our units we'll just leave as c over a for now. Okay, we'll talk about that would break down to seconds later, but for right now we'll just leave it as c over a.
Now you can also see these 3 sample problems in separate video files on the playlist. So if you want to go back and look at any one of them individually, you can do it in that manner. Thanks for watching. This has been the Scientific Adventures of Beardman.